right? But just like when we talked about attribute queries, right? When we talked about, we spent a lot of time talking about these possible comparisons. I want to spend a lot of time talking about this idea of the relationship, right? How can we define, or what are some common ways that we define the spatial comparisons, right? And so just like with the comparison and the attribute query, right, there are a lot of options that we can have for this spatial relationship. And in fact, there are usually more than a dozen different options within most GIS frameworks. But what I want to talk about today are the most common. We're going to talk about 5 or 6 of the most common. And so when we talk about relationships, again, just to be clear, what we're actually talking about is the idea that we have a spatial relationship or a spatial comparison between the input features and the selecting features. And so what ends up happening is we end up defining our spatial relationships with keywords that tell the computer or the software, hey, compare the geometries this way. And so what I want to do is I want to go through each of the options. I want to talk about what they mean in terms of what they're looking for, and then show a diagram of sort of what's happening so you can get a feel pictorially for what the different options are doing. So the first option that I want to talk about is something called intersect. Now, intersect is sort of the default for most software packages. When you start doing spatial queries, 9 times out of 10, it's going to default to intersect. And basically what intersect does is intersect says, does any part of the input feature right, does any part of the input feature overlap any part of any selecting feature? Right, so the idea is basically, does any part of the input feature overlap any part of the selecting feature? This is the least restrictive in terms of how we can handle a spatial query. All right, so let's go ahead and take a look at what that looks like graphically. When we're talking about intersect, right, what we're talking about, again, is this idea that given a set of input features, so in this case, right, the input features are in red, right, the selecting features are in yellow. So in this case, we're saying, hey, given the input line features, intersect them with the selecting polygon features, right? And so what we do in the output is we highlight them in blue to show that they're selected, right? And so what happens with intersect is we're saying, hey, for each input feature, right, check and see if it overlaps in any way, shape, or form one of the selecting features, right? And so if we look at the output, we can see that this feature got selected, right, because it kind of overlaps right here. This feature got selected because it's actually completely inside of this selecting feature, right? And then this line here, which is actually along the boundary of this polygon here, also got selected, right? Because all 3 of these intersect, right, or overlap in some way, shape, or form, right, the selecting features. So that's intersect. The idea that we have inputs, if they touch at all the selecting feature, we count them, right? This one did not get selected, right? It's still red because it did not touch in any way, shape, or form any of the selecting features. So we have other options as well. Another popular option is what's called within. Right? And what within does is within says, hey, give me back an input feature that is inside of a selecting feature, right? This is going to say return all input features, right, that are completely inside of selecting features. Right. Return all input features that are completely inside of selecting features, right? Completely inside. Right. And it's this completely inside piece that makes this different from intersect, right? Because intersect just said, hey, if you touch, that's good enough. But within, right, says that all of the geometry is that the input feature has to be completely inside of the selecting feature, right? And if we wanted to get a little bit more technical, right, when I say completely inside, what this means technically, right, is that all coordinates for a feature right must be right inside the selecting feature. Right. Again, this completely inside is the key distinction here. And let's go ahead and look at sort of graphically what that looks like. Right. And so what you'll see when we run within, right, this is the exact same input as our intersect. But when you run within, what happens is, right, in the output, right, this line here no longer gets selected. And the reason why it doesn't get selected is because, right, this piece here and this piece here, right, fall outside of the selecting feature, right? This one's fine because it's completely inside. This one shares the edge, which in this case would count, right? In some software, this actually wouldn't count, but for our purposes, right, it's considered within because it's sharing the exact same boundary. But the key difference here is this piece here, where because we have this part of the line here and this part of the line here outside, this is no longer considered to be within. So within requires the input feature to be completely inside of a selecting feature. So that's within. Right. Another popular option is shares line width. Or sometimes you'll see it called shares boundary. Right. And so what shares line width and shares boundary does is it looks at whether or not the input feature right shares a line segment with the selecting feature. Right. And so you can imagine this might be useful in cases where you have, say, rivers and municipal boundaries, so like the boundary of a county, right? Oftentimes, right, you will have situations where political boundaries follow along natural features. And maybe you want to select all of the natural features that share the boundary with a particular municipality, right? So what shares line width or shares boundary will do is it will only grab the ones that share a line segment, right? So let's go ahead and take a look at what that looks like, sort of pictorially, right? So if we have the same input from before here. If we run share line width on this data set, right, what we get back is this piece only, right? Because this case, right, it's going through it, it's not the same, right? In this case, it's inside of it, so it's not sharing the edge. In this case, right, this line segment from here, right, is the exact same line segment as the top boundary of this polygon, right? So when we want to get the feature that shares a line, what we're going to get back is this line feature here, because it's the only one that is coincident or the same as, right, the top of this polygon. So again, what share line width or share boundary does is it grabs the input features, right, that have the same geometry as part of the selecting features. All right. So we're going to change tacks a little bit here, and we're going to flip the input features from the lines to the squares, and we're going to talk about a similar concept to within. We're going to talk about something called contains. Right. And what contains does is contains actually pulls out input features, right? Returns input features. Right, that have selecting features completely inside them. Right, so contains returns input features that have selecting features completely inside them. Now, hopefully you can see the subtle difference between contains and within, but if you can't, I just want to make this abundantly clear, right? Contains looks at whether or not the selecting feature is inside the input feature, right? What within did is within looked at whether or not the input feature was inside the selecting feature, right? You know what? I'm actually use a different color here because I want to make this point abundantly clear. Let's go ahead and use yellow, right? Within versus contains. Right, for within, what you have is, right, the input feature, right, is inside the selecting feature. Right, with contains, you're saying, is the selecting feature, let's try and spell selecting right here, right, the selecting feature, right, is inside the input feature. Right, so this difference, this is critical. This is the critical difference between within and contains. Within says, hey, give me back things that are inside the selecting feature. Contains is saying, hey, give me back things that have the selecting feature inside them. So let's go ahead and look at a pictorial example of what contains looks like. All right, so in this case, right, it's the exact same data set. All I've done is flip the colors to keep it so that the input feature, so the thing that we're selecting from, is in red, and the selecting feature, right, the thing that we're comparing against, is in yellow. So this is the exact same data set that we've used before. I've just flipped the colors so that we are consistent with our color scheme here. But you can see that if we take this data set and we apply the contains relationship to it, right, what we get back in this case is this polygon here, right, because this polygon has this piece of line here inside of it, right? This polygon contains this line, right? And then this polygon, right, contains this edge piece right here, right? But you'll notice that this one is not selected, right? Because this line here is not completely inside of it, right? Again, just like before, part of it's out here, part of it's out here, right? Actually, yeah, right? See this part right here, and this part right here, right, invalidate that selection. Right, so we're good here, and we're good here because this is completely inside, and this is actually along the edge. So in our relationship, the way we define it, right, this is considered to be contained. So there is one last relationship that I want to talk about, and that is going to be using distance. Right? Sometimes you'll see it within distance of. Right? Or distance. And the way that this works is exactly how it sounds. Right? This allows us to give a specified distance and grab all of the input features that are within that specified distance of a selecting feature. Right? So this is going to return, right, all input features right, that are within a specified distance of a selecting feature. Right, so in this case, right, what we're doing is saying, hey, we want to know, given the selecting features, right, how many of the input features are within a specified distance. So you can imagine this might be useful if, for example, you wanted to widen a road and you wanted to know how many fire hydrants, right, are within the distance of that road based on how much you're widening it and any additional area that you would need for construction purposes, right? So that you know that you have to reroute these fire hydrants. That's just one example. But the idea here is that we're going to give a distance. We're going to get all of the input features that are within that specified distance. So one note here, right? With distance, right? You must specify a distance. Right? This requires an additional parameter that the other ones did not. Not only do we have to specify that we want to use distance, but then we also have to tell it what that distance is. So let's go ahead and look at another example. So in this case, right, the distance we're using here is 10 kilometers, right? And so I've changed up the geometry a little bit. In this case, right, we have the exact, let me switch over to that, right? We have the exact same lines as before, but I've replaced the squares with points. Now, these dotted purple sort of ellipses here, these represent 10 kilometers. That's just visually for you to realize that what we're doing is actually correct. Right. So when we say, given the lines and a distance of 10 kilometers, right, give me all of the points that are within 10 kilometers of the lines. And you can see here, right, again, our points are highlighted in blue if they're selected, right, that we've actually done that. That given the yellow line here and the 10-kilometer distance, we've selected all of the points that are within 10 kilometers. So that's how distance works, right? You give it a distance, you give it some selecting features, and then it'll look for all of the input features that are within that distance. Okay. So hopefully you understand the different relationships. I'm actually going to quickly just add a blackboard here, and I want to just recap, because we've talked about a lot of them, what we've actually done. So we have intersect, right, which is basically return any feature, input feature, right, that touches, right, in any way a selecting feature. Right, we had within, which returned selecting input, which returns input features that are inside selecting features. Right, we had contains, right, which is kind of the opposite of within, right? It returns, right, input features that have selecting features inside them. Right, we had the idea of share line or share boundary, right? This returned input features, right, that share a line segment with the selecting features. Right, and then finally we said within distance of. Right, and within distance was set up such that it returned, right, input features, right, that were within a certain distance, right, of selecting features. Right, so those were the 5 different relationships that we kind of went through. You just kind of got to learn to keep track of them. I know a lot of them are actually, they're pretty intuitive, kind of once you get a sense of what spatial queries do. I think the verbs here are actually pretty intuitive.